Mic check. Okay. Good morning. Thanks for being here. If you're able to join me this morning, if you're watching later, hope you're having a good week. This is our last week of official content, sort of content that matters for the final exam. So you all did a poll last week where I asked you if you wanted to see me do a service installation like a database or a web server. So web server won, but if I do this next week after I do a quick review for the final exam, I can probably do maybe a web server combined with a database system and then do a little web application that uses it. So web server won the poll, so next week after I do review, then I will do bonus content and we will install a web server, probably Nginx is the one that I currently use. And then possibly a database system. I'll see what I can fit in to roughly an hour or so. There was also some votes for a secure shell so that you can log in remotely. So I might be able to combine all 2 or 3 of those things into one. Anyway, so just so you know, next week will be next week is the final exam week for you guys. So this is the last week when you have a lab and a discussion to complete. So next week during lecture, I will do a quick review of all the things that you will expect to see on the final, and then your final will be your only assignment. But at the end of the review next week, I will switch over and do an hour or so, I think, of bonus content based on the polling results. Yeah, so that's mostly it, I think. So has some notes here on the side about what we're covering today. So we're covering the null device and using the find utility, and then finally adding to our scripting capabilities by creating bash shell functions. So the reason why I waited until find at this stage is because I actually like to write shell functions that use find. For whatever reason, I have never been able to memorize all of the different things that I find useful about the find utility. So what I've ended up doing is writing bash shell functions to capture that functionality. Pardon me. The other thing, the reason why dev null is here is because I find dev null in combination with find to be extremely useful. And I'll show you how those work together. So that's our plan of attack for today. Week 16. Oh, team project 2. So I will get those graded in the next few days this week. So you'll get those grades back. But most of you know what to expect, and if you did as good a work as you all did the first time around, then that won't be any stress, and probably you're glad at least to have it past you. All right, let's go look and see what is happening this week. Apologies if you had looked and seen that the goals were messed up for whatever reason. In my scramble to get all the content up earlier in the semester, I forgot to update the goals, so I've done that this morning. So this week we are doing using the null device, which most people just say dev null. We will experiment a little with the find utility, which is super powerful. And then finally we will write some bash shell functions so I can show you how those work, which add to your powers in shell scripting. Reading, so there's a bit more readings, but it's because I didn't like the way our textbook covered the null device, so I found a Wikipedia article about that. And then the find utility is sufficiently complicated where I thought it would be helpful if you had, in addition to what I'm going to say, a walkthrough in an online tutorial. So find is a way to seek out files and directories on your system with a whole bunch of different parameters attached. So you've probably used find in a Windows environment, for example, or if you're on a Mac, you may have used their whatever they call that utility to say I'm looking for a file or an application of this name. But the find utility in Linux is far more powerful than that. You can seek things by when they were last modified. You can seek things by their size, by their owner. You can seek things based on the fact that, based on what kind of file they are, and you can anchor your search, your find, in any directory in the system, and then you can also control from that point how deep into the system it goes. It's very, very powerful. So if you're a sysadmin type and you work in a Unix environment, very much worth your while to figure out how to use find and leave yourself some breadcrumbs so that you remember its existence mostly, but also some of the basic features that it offers you. It's very, very powerful. And for me, once I have identified a way to use the find utility that I like a lot, I will often embed it in a shell function. That way I don't have to remember my fancy setup. I just have a shell function for it. And I'll write an example or two of that. Okay, so lab as always, this one's probably shorter. Not 20, I think, probably 10 this week. Okay, so I wanted to tell you about the Piazza discussion, which it looks a little bit scary and big and long, and oh my goodness, we have to come up with 5 utilities and a brief description of each utility. But I wanted this Piazza discussion to be an opportunity for us all to contribute to a big discussion that becomes sort of a semester-long review at the same time. So what I'm hoping will happen is that you'll do your little bit of research and thought about this and write some notes for yourself. And as you're doing that, you are sort of tying up your semester's experience and with your sort of major takeaways, and then you can also see what your classmates noted down as the major takeaways from their semester's experience. So my hope is that that is in some way useful as warming up, reviewing in advance of the final exam next week. And then finally, next week is the final. So just like the midterm week, next week we will have a review. I will do some bonus content on Tuesday morning, but your only assignment the whole week is the final exam. It's due, as all assignments are, by midnight on Sunday, which is December 20th. So you have the whole week. Just like the midterm, the final you only have, once you submitted it, it's done. You don't get to resubmit it like you do the weekly labs, but there's no time limit on it. So you can start it and then finish it whenever you want. Just make sure that when you click submit that you're aware that you're done. You can't redo anything. But other than that, there's no time limit on it. Okay, so there we're at with what's happening in the class this week. Let me switch the view up and let's go toy around with some of these utilities. I really like shell functions. I like shell scripting, but I write tons of shell functions for myself. Every time and aliases for that matter. I really like aliases and shell functions because they allow me to capture commands, sometimes the more complicated commands that take me a while to figure out how they work. I immediately put those somewhere, and then often if I find I want to use them again, I end up making a function to so that those commands sort of in all their fanciness are always available, but with a short function name. But I'll show you what I mean by that. Okay, so we're going to start with the null device, just the basics of it. Sorry, I'm trying to get my screen where I can use it. Okay, so the null device is, some people will call it a black hole. In fact, I will add that. But it gives you a convenient place to redirect some of your command's outputs to a place where they don't affect anything. So if you redirect something to dev null, it just goes away. It disappears. It's just sort of consumed. And I'm going to give you an example of that. So for example, if I say echo hello, the output of that command is just the hello, and it goes to the screen. Now I can also, if I want to, redirect it to a file. So the output, instead of going to the screen, which is where it would go by default, has been redirected to a file. I can cat that file out, and there's the hello that would have been echoed. But you can also take things and redirect them to dev null, which is a black hole in the system. It's just gone. Now, in terms of this echo, that seems completely not useful. But I wanted you to sort of get the basics. The null device, the way it is commonly used is to redirect outputs from commands that would otherwise be an irritant. So let me give you an example of that. Let's see, if I do ls/root, okay, I'm going to get a permission denied, and it turns out that this is actually an error message. So I can, let me think of a better one. What if I do ls-bin? Do I get any permission denieds? I don't. Do I get any permission denieds here? I'm looking for a place where I might get some permission denieds. We'll have to use find to actually get this. Okay, but anyway, when I tried to list roots, I get an error message. And I can, with this to, what this says is take all the errors and redirect them to this black hole so that I don't see any errors. And what I need to do is cook up one where the errors don't print so that you can see that. Let's see if I do a remove. And I'm going to have to go, hold on. All right, I have an alias somewhere that I don't want. Let me get rid of that alias. It's still there. I want to scrub that alias off. Okay, I want to get rid of that stupid alias. But what I want to do is just point out for you, if I try to remove some non-existent file, I get an error. Now, if I remove a non-existent file and also hello.txt, it removes hello.txt, and then I get an error from nothere.txt. So if you see the listing, it succeeded in removing hello.txt, and then I got an error on nothere.txt. So the same kind of thing. I can remove some stuff. And if there are any errors emitted by it, I can redirect them to the black hole so that I don't have to be bothered by the errors. Now, you don't always want to ignore errors, but this is the most common use of the null device, is to take errors and redirect them to the black hole. Now, this 2 right here means just the error outputs, and you're going to see this again in just a second when we start using find. So the most common way to use the black hole, the null device, is to take errors from a command, which is the to greater than. So to means all the errors, not the regular outputs, but the errors only, and redirect them to the black hole so that all you see is the good stuff and you don't see the error stuff. Okay, so where this comes up though a lot is using the find utility. So we're going to use find, and then we can use the black hole to eliminate all the error outputs. So one thing we can do is use the find utility, and the way you set up a find command is you find starting at what location, what directory. So I'm going to say find starting from root, and I want to look for everything owned by a user. So the dash user means I'm about to tell you which user I'm looking for. Let's just say me. I'm called user on this system. So find everything starting at root that is owned by the user, that's the dash user part, named user, that's the user that's undashed part. Now if you do that, you get a whole bunch of permission denieds, a whole bunch of error outputs, but mixed in there, if you can see here, I have var spool mail user, and then a whole bunch of other stuff that I own. So mixed with the outputs of the stuff that user owns is a whole bunch of errors because I didn't have permission to actually read the thing. So this is a great place to use the black hole device, is to do a find through the entire system for everything that I own. So dash user means which username, and then the username I'm looking for is user. That's the username I have on the system. But I want to take all the errors and redirect them to the null device, the black hole, so that all I see is the successful parts and not all that wall of permission denied. So here we go. So everything that comes out now is just the stuff I own, and all of those errors that were associated with me not having permission to read the thing, those are redirected to the black hole so that I don't have to see all that error output. All I see is the good output. So that's the most common use of dev null, is to redirect errors. That's the 2 greater than. So the greater than is redirect. The 2 means the errors, not the good outputs, but the error outputs. Redirect the error outputs only to the black hole so that I don't have to look at that mess. And I frequently use this redirect with find commands because I know that as I'm searching through a system for files that I own or for files based on other attributes, I'm probably going to get a lot of permission denied errors, and I don't want to see that stuff. So there's an application of dev null. I don't want that command. Okay, so that's how you'd use it. You would say some command, and if you know you don't want to see the errors, like with a find that often produces lots of errors, you say, I want to take the errors, that's 2, I want to redirect them to the black hole. Now you can, by the way, redirect them to a file if you want, and then you can go read the errors later. So you don't have to redirect them to the null device. You can redirect them to a file. So that's a handy thing. Okay, so a couple of other find options. How am I doing on time? Just fine on time. A couple of other things. And if you do some Googling, you'll find there's lots of other things you can do with find. You can actually run a find command that actually then applies a secondary command behind it. But I'm just going to do the basic, how do you find things based on different parameters. So find, the way you set up a find command is you say starting from what directory, and by default, find will start in that directory and then descend into all the subdirectories from that directory. And then you give it some parameter, and then some parameter, some value for that parameter. Now this is just a template, so that's typically how you do it. So we did, so for example, find home. So I want to start in home and descend to all the subdirectories of home, looking for anything owned by a specific user. That's the parameter. The value is the user, me, which my username is user on this system. So it's going to start in /home and then descend all the subdirectories from there, which is a lot. Okay, so that's one use, is looking for a particular username. So I'm in my home, so I'm going to use the present working directory, which the shell shortcut is dot. So find starting in the current directory. You can also search by name. So you can search for a specific name, like file.txt, and it turns out that from this directory and its subdirectories, there's actually 3 of those. There's one in the present working directory, there's one in the week 7 subdirectory, and one in the week 10 subdirectory. You can also use wildcards here, so you can say all the .txt files. So as the name, I'm wildcarding all the .txt files, which is a lot. Or all the shell scripts. Right, so there's all my shell scripts in this directory and descending into subdirectories. Is another way to use find. Super cool if you're a sysadmin type especially. This is hyper powerful. We can also search by modification time as an example. So I can say anything older than 14 days ago. The dot means to find starting in the present working directory and all of its subdirectories. Modification times that are 14 days ago or greater, which is a lot. That's a lot of files. Let's only go back like 3 days. Have I touched any? Also a lot. Oh, greater than 3 days, probably. Anyway, so you can use the modification time, and you can tell it a number of days, and it will list for you files by the modification time. You can also do files by type. This D means directories, so find in the present working directory and all of its subdirectories, all of the entries whose type is directory. So here's all my directories. You can also do size, and I think you can say like +1K. I wish that Mozilla stuff was. I'm gonna remove the Mozilla stuff so that doesn't come up anymore. Oh, I already did that. Hey! Oh, there's a cache too. Okay, that's a little bit better. So anyway, you can also find things based on the size parameter, the modification time of the user who owns it, the name, and you can wildcard the names to look for things that are specifically by their name or some variant based on wildcarding. Has a whole bunch of options. It's not the easiest man page to read, which is why it's helpful to find a tutorial online to help you. And I'll just scroll down and look at some of the options if I can find them. Okay, so there's different ways to do the times, and this just takes experimentation. You can control the depth, so how many subdirectories should the thing descend before it stops, which is max depth. Anyway, there's a variety of options, and then the tests you were seeing, we're looking for greater than a value, or less than a value, or exactly a value, so you can use those on the size, you can use those on the modification time, and then you'll notice here's a whole bunch of access times. So when is the file last accessed, which would be a good way, I guess, to look for people who are broken into your system. Change times, whether or not something's executable, etc., etc. I'm just showing you the man page, and if you're a sysadmin type and you're working in a Unix or a Linux type environment, I suspect that at some point you're going to find you will have an opportunity to use find, and it is very powerful with huge amounts of options. I am not a find power user myself. I'm just aware of the fact that most search requirements that I might have in a system for a file or directory, find will satisfy them. And it may take a while to work it out, but once you've worked it out, then you can save that find in a shell script or inside of a shell function. And then you don't have to write it another time. So anyway, that's find. I've written questions in the lab this week that encourage you to try find with some different options to see what they do. So hopefully as you're working through this week's lab, you'll stop and run those commands just to see what they do. Some of them won't work, some of them will work. So I'm going to do, let's say, let's go to root and find things that are bigger than, let's say, 10K. And I'm just going to remind you one last time before we move on to shell functions. This is going to explode with permission denieds. It's not entirely permission denieds, but it's a lot of permission denieds. Let's try 100. Do I have anything bigger than a meg? I do have some things bigger than a megabyte. So I wanted to point out to you that a whole bunch of error outputs came because I had a lot of permission denied. So that might be a good place where, well, if I don't have the permission, then I'll just send that to the black hole device, and I will just look at the ones that I have permission to look at. So there they all are. I'm just going to keep going to see if I have any that are greater than 5. There are some greater than 5. Are there some greater than 10? A few. Greater than 10. What about 20? Still some that are greater than 20 megs. So that's just a whole bunch of examples of using find. And those last ones I was redirecting the errors only to dev null so that I could just see whatever sort of good output I can see. Okay, so that is the find stuff. Let's do some shell functions. So a shell function, there's a couple of ways to write this, but because the shell is actually sort of it's an interactive scripting environment, you can actually make functions right here in the shell. So I can say, for example, I'm going to make a function. So the way you write a function, there's two ways to do it. This is the way I do it. You put the function's name, say hello, and then empty parentheses, and then you open up a curly brace. This is how I usually do it. And when you press enter, you'll see that you don't have the prompt back yet, because when you opened up that curly brace, the shell is waiting for you to close it again. So now I'm going to put what I want. What I want the function to do. And notice I still have the weird secondary prompt, not the main prompt. So I haven't closed the curly brace, so I'm still sort of, I'm going to backtick the date here. Remember, the backticks cause the command to execute, and then its output is placed in that spot. And when you're done, so I'm going to close the curly brace. And what I will have at the end is a function named say hello in my running shell environment that will say hello Boyd and then tell me the date. So once I press enter here and the shell realizes that I closed the curly braces, I'll get my main prompt back. Now if you're doing this along with me and you get errors, you can always go back. If I arrow back up, there's my shell function all collapsed by the shell, and then I can fix any mistakes. So this is how the shell actually collapsed my function after I wrote it. But I can use that to go edit it. Okay, but what does a shell function do? Well, it basically becomes a command just for you. So here's my shell function. It's a command just for me in my shell. Now I'm going to show you one downside to shell functions here in just a second. So here's a shell function, say hello, and every time I run it, it will run those two echo statements that are attached to the function as I defined it earlier. Now if I log out, the function's gone because I had actually entered it into my prior environment and it wasn't restored. So the way I do this is a two-step thing. And it could be bash profile. I make myself a dot file called bash functions. So I like to have a file called .bash_functions. I source that into my running environment using .bashrc, and then every time I log in and get in a shell, I have my functions available to me. So I'm going to walk through this process real quick and show you how I do it. I need to make sure I'm home, so cd enter takes me home, but I'll double check I'm home. So the first thing I'm going to do is I'm going to make, and I'll slow down here a bit, I'm going to edit a file and call it .bash_functions. Now, there's nothing special about that file or its name other than putting a dot means it's hidden. But I also just think it makes it kind of obvious what it probably is. So bash doesn't automatically understand the name of this file, bash functions. It only has a few files that it knows, like .bashrc and .bash logout automatically. But I'm going to follow the same pattern as those other .bash files and put my functions in a dot file. All right, so this is where I would create my functions that I want to have part of my running environment every time I log in. So now I'm in my .bash functions file. I'm going to create my say hello function again. Backtick the date in, and then close the function. You can do other functions as well. So I'm going to make just a garbage function at first. I'm just going to say so the add one is just going to pipe some math into the BC calculator. So BC is going to receive 1 + 1 and presumably print out 2 as a result, but we'll see it when I run the function. Anyway, so the point here though is that you can make a lot of functions, and if you save them in a file and then source that file when you log in, then you will have your special custom functions available to you, and I love doing this myself. So let's try it out. That's just going to be 1 + 1 = 2, but I'm setting up for something. Okay, so there's that. I'm going to write it first. So that's .bash_functions. I have two functions in there. A say hello function and an add function. Now you want to be careful that you don't name functions that ghost or overlap. So you don't want to make a function called rm unless you know that you're going to lose your convenient access to the remove utility. So I try to avoid reusing the utilities names and come up with names that I know there aren't any utilities that do that. Okay, so there's that. Now I'm going to go to my bashrc file, which I know is, this file is automatically processed by the shell. So what I want to do here is every time bash rc runs, I want it to source my bash functions. I should be careful here. Make sure it's referring to... so this is my bash rc file. I'm going to have it every time bash rc runs, I'm going to have it source my functions so that every time I'm working in the bash shell, I have my functions that are defined in bash functions. Hopefully I'm not going too fast. So as it is right now, if I type say hello, that's not in there because bash functions hasn't been sourced yet. So the first thing I'm going to do is I'm going to log out, and then I'm going to log back in. And what I'm hoping happened is that bash rc was just processed, and say hello is now available to me. Oh, bash rc wasn't processed, probably because I have a bash profile. I have a bash profile. So let me go, do I have a bash profile? I do have a bash profile. So let's source it there. So it's picked up when I log in. So I added that sourcing to my bash profile instead of my bash rc. This matters when you start using a GUI, by the way. You'll want it in bash rc. In fact, why don't we make dash profile source bash rc instead? So let's make this number 2, 3, so number 1. We'll kind of just cause it to cascade. So we'll have bash profile, so that's my login. So when I first log in, it will source .bashrc, and then if I'm running in a desktop environment, a graphical environment, and I open a terminal, that's going to run bashrc, which will by extension. So if I log in to a text environment, my bash profile will cause all the bashrc stuff to happen, which will cause the bash function stuff to happen. If I'm running in a graphical environment and open a terminal, bash profile doesn't execute, but bashrc will. So if I'm working in text or on a graphical environment, I'm going to guarantee myself that I get my functions loaded. Sorry, there's the problem. Okay. But I'm just sort of making sure first. Okay, so now say hello works. If I do add, by the way, that now also works. So I have those 2 shell functions available to me. So I'm going to go fix my functions, because what I would really like to do is say like add 1 and 2 and have it say 1 plus 2 equals 3. Now as it is, it's still doing 1 plus 1. So what I want to show you is that functions are like miniature scripts. They can take positional parameters. So instead of 1 plus 1, I'm going to take $1 and $2. That will be the first argument and the second argument to add, and then pipe those in to BC. I'll slow down a bit. So now add expects to get 2 arguments. And just like a shell script, more or less, it's a little miniature independent shell script that gets its own arguments. So it will take the first argument and the second argument and pipe those being added together through BC, which will do the calculation, and we'll get our result. So I'm going to write and quit that. This time, instead of logging out and logging back in to get my updated functions read into my environment, I'm just going to directly source. So you can source your dot file from the command line, which will reread it will reread the definition. So now my add function expects 2 arguments. I'll give it 2 and 3. It adds them together. I get 5, which is kind of neat. Let's see what happens if we don't give any. So if we don't give it any arguments, we get an error, and that's because it was expecting 2 arguments. So we can fix that as well. And then I have one more example after that, and I think we're probably good to go. So let's go improve. So they're like miniature shell scripts, which means that just like a shell script, so just like a shell script, we can actually see how many arguments it's receiving. And if it's not receiving 2 arguments, we can put an error message out, just like we would in a shell script, that says, here's how you ought to be using this. Otherwise, if we get the 2 arguments we need, we'll run the math. So they're like miniature shell scripts, and that's super powerful because you can capture some sophisticated behaviors here. All right, let's try it out. So write and quit. I want to resource it. And now if I type add, I get the usage. If I try to add one number, I still get the usage. Should be 35. Otherwise, I get the result. So I actually like to write these kinds of functions for myself, or I can just do some quick math on the command line. So an example, I don't need to do, well, I might do a script. So anyway, this is the way that I find myself. I frequently make shell functions like this, especially when I want to have it flexible with different arguments. I will often use it. But also I write a shell function sometimes simply because I've figured out a very complicated command that I like a lot. I will put that command inside of the shell function and give the shell function a name that I can easily remember. And then whenever I need that complicated command, I just type the name of the function and off we go. Now another thing that you can do though, you can script with functions. So let me see if I have a directory for this week. I do. All right, I don't have any. So I'm just going to show you one more example. Yeah, see if we can work out the math. So you can also use functions to organize a script, and I'll just give you a quick example of that. So let's say we're going to make a little game. So we could have a start function. Oops, it's a shell script, shebang. So we can put functions inside of a shell script. So let's say at the start of the game, welcome to the game, maybe a blank line. Do I want read? Maybe. Name. There's a start function. We could have them like go into a dungeon. I know not everyone's into the game thing. I just wanted to show you a quick example of organizing a script with functions. So you can make functions and then you can use those. So you can call your functions in here. And you can pass them arguments if you want. But let's just see how that works. So you can use functions inside of shell scripts, is the point, to organize the contents of the shell script a little bit better. Let's see if it works. That start being yellow concerns me, but let's see what happens. So lines 13 and 14 are causing the functions to execute. Right, so I'm going to execute start, and then we're going to execute dungeon, and then the game is over. So I need to make this executable. So there's the two functions of my shell script running, and just sort of pointing out to you here that functions are very handy for organizing complicated scripts. And you can still, what's the thing that I'm looking for here? Let's see if we can pass the name in. I'm not sure if this name is going to be globally available or not, but I'm going to try it and see what happens. If not, then I'll go fix it. My guess is probably not. Oh no, it worked. Okay, so it is globally available. I'll run it again so you can see. So I have one do the name and then the next one uses it, and the way I did that. So I did start, and then I passed the name that start created through to the dungeon function, which received it as its first argument and used it. So you can also make variables and pass them around. You could at the end, for example, say you could at the end echo game data into like a hidden save game file if you wanted to. Now it's not just for games, of course. So I'm going to run that. Now let's cat out the save game file, and there's the name that they type. If I run it again, then there's the... So this is just a reminder that scripts are really just ways of capturing series of commands. All the commands that we've been practicing all semester, if you find a combination of those things that help you perform a task, especially if that task is complicated or repetitive, then shell scripts or functions, which are really just sort of think of them as miniature shell scripts, great ways to save yourself future trouble and make yourself more productive is to learn how to use bash functions or any scripting, any shell environments functions, and scripting to organize and save complex or useful commands or sequences of commands. So that's a lot of words to describe this thing. I hope that all makes some kind of sense. This is the basic operator course for Linux again, so we're not looking to emerge as expert shell scripting people, but I do want you to exit the class having some sense of what's possible in the command line environment in Linux. So all kinds of utilities that we've been practicing all semester, and then the last few weeks of the semester we've been looking at how would I take those utilities and package them up to perform more complicated or repetitive tasks, and that's what scripts and functions are for. So hopefully you come away at least knowing that, and when it becomes useful to you, then you can probably with just a little bit of research or a little bit of refreshing, figure out how to build a function and or a script that has those operations that you want in them. Okay, so again, too much words. I think that's where I'll stop for today. Hopefully I've armed you with everything, or at least most of what you need to get the lab, with the addition of a little bit of reading and research. So thanks for being here if you were able to be here today. If you're watching later, thanks for watching. I hope you're having a good week. This is our last week of new content. Again, next week we will start with a quick review of what to expect on the final, and then I will go into a bonus content section where I will install at least a web server, and then possibly secure shell so we can log in remotely to a system, and then possibly on top of that a database. I'll see how much time I have, how much I can squeeze into roughly an hour, but there will be probably about an hour's bonus content after probably about a half hour of review next week. So I hope to see you then, but if not, hope you're all doing well. Thanks for a great semester, and we'll use next Tuesday's lecture to get ourselves ready to finish strong on the final. So have a great day, and I will see you next Tuesday. Same time, same place. Take care.